All right, before we go into this next example, let's talk about some geometry real quick. Suppose I have two lines that are parallel like this, okay? And then I have a line that cuts through them like that. Well, this angle and this angle is what we call alternate interior angles. Also, this angle right here and this angle right here are also alternate interior angles. Why? Because they alternate on both sides of this transversal, and they're interior, or they're on the inside of these parallel lines, okay? So what do we care about alternate interior angles? Well, they're congruent, they're the same measure. Let's suppose I have two parallel lines like this, okay? And I have a transversal that cuts through them. Isn't this right here, like, let's just say that's 12 degrees. Well, that can't be 12, that could be 120 degrees. Let's just say that's 120 degrees right there, okay? The alternate interior angle is going to be congruent, so that's going to be 120 degrees as well, okay? And what would that make this? That would make this what? No, not 50, 60. 60 degrees. And the alternate interior angle would also be 60 degrees. So two parallel lines cut by a transversal, alternate interior angles are congruent. And that holds even if I don't go all the way through these, okay? Like if I have a transversal like that, still have alternate interior angles are congruent. All right, so we're going to use that to work this next example. On the next example, it talks about two boats leave a marina at the same time. The first boat travels 6 knots at a bearing of north 39 degrees east. Let's draw a picture of that part. All right, let's suppose this is my compass. North, south, east, west. Okay, it talks about the first boat at a bearing of north 39 degrees east. So it's going to be going something like this. North, 39 degrees east. That's this angle right here, okay? And then it talks about the second boat travels, okay, leaves a marina. Let's assume this is a marina right here, so that boat goes that way. Then we have a second boat that's going to leave this marina, go like that, or whatever, okay? But it says the second boat travels at 4 knots at a bearing of south 87 degrees west. So that's southwest, like this, and this is 87 degrees right here. Okay, then it wants to know how far apart are the boats at the end of 2 hours. So it wants to know what is this distance from one boat to the other. One boat to the other. What is this distance right here, okay? Well, let's see. First thing I want to do is I want to find out what is this angle from this line to that line. What is that angle right there? Maybe I can find a different color here to mark it. So what is this angle from here to here? Well, if this angle is 87 degrees right here, wouldn't that make this angle 3 degrees right here? Because if I go all the way this way, that's 90 degrees, right? So 90 minus 87 is 3. All right, what is this angle from here to here? That's just 90 degrees, right? So how would I find this purple angle right here? How would I find that purple angle? I would say 39 plus 90 plus 3, right? All right, I don't really have a place to draw it. I'm getting too cluttered here. So what I'm going to do is I'm going to redraw this triangle over here without the coordinate plane, okay? So I have this, I have that, and I have this with my triangle, okay? Now what do we say if we add 39 plus 90 plus 3? We'll get this angle right here, okay? So let's see, 39 plus 3 is 42. 42 plus 90 is 132. 132 degrees right here. Now, what is this side of my triangle. It talks about my boat leaves the dock in, how fast does it leave? At 6 knots. Okay, so that's 6 knots or 6 nautical miles per hour. So that's 6 nautical miles per hour times how long does it travel for? Okay, well, Port A says, how far apart are the boats at the end of 2 hours? So at the end of 2 hours, it'd be 6 times 2 or 12. 12 nautical miles. That's how many nautical miles per hour times the number of hours. All right, now what about the second boat? Travels at 4 knots. So this one travels at 4 knots. And after 2 hours, it's going to be 8 nautical miles a distance. So if I look at this triangle here, what do I have? Side, angle, side, right? Law of cosines. Now what do they want me to find? They want me to find this distance right here, okay? So they want me to find the distance in this dashed line. I can call it whatever I want to call it. I don't know, maybe I'll call it A. Okay? So how do I find A then? Well, A squared is equal to what? The lengths squared added together. So 8 squared plus 12 squared minus 2 times each one of those lengths times 8 times 12 times the cosine of the angle opposite of side A. It's cosine of 132 degrees. All right, so you can take the square root of both sides now and put all that in your calculator. Make sure you're in degree mode, of course. And whenever I did this, I got something like 18.3432 is my A value. All right, so Port A asks, how far apart are the boats at the end of 2 hours? It didn't really tell me how far to round, so I'm going to round to 1 decimal place. I'm going to say the boats are 18.3 nautical miles after 2 hours. Let me just go ahead and put up here too. That's 18.3432. All right, let's look at B. What is he bearing from the first boat to the second boat at this time? So what is this bearing if I were going from the first boat to the second boat at that time? So what is this bearing right here? Well, if we look at a compass, the bearing is going to be what? Some kind of southwest, right? But I need the exact what? Measurement and so forth, okay? So I need the exact measurement and so forth. Let me grab my other color here. And let's see something. All right, so here is my north-south line right here, okay? What if I kind of duplicate that over here with a dash? And say, okay, there's my north-south line, okay? And what do I know right here about my north-south line? Think about this for a second. Step back and think about this for a second. You know that right here, this angle right here was 39 degrees, right? 39 degrees. So I can say that this angle right here is just like this angle right here, are 39 degrees, okay? Now, what if I drop a perpendicular line to this one, I'm sorry, parallel line to this one over here? What if I draw a parallel line to this line right here, okay? Do you see where I'm going with this? Parallel lines, and I have a transversal now, right? So what do we talk about? This angle now is alternate interior with this angle, right? So that angle's what? 39 degrees right there. That angle is alternate interior with that one, 39 degrees. So how do I find where my boat's heading? Let's see. So I would need to find this angle, and then together this angle plus that angle will give me my bearing, right? So let's find this angle first. Let's go ahead and call that angle theta, maybe. That's just this little angle here. How could I find theta then? Could I use the law of sines? Could I say the sine of theta over 8 is equal to the sine of 132 over this 18.34 number? Sure could. So I'm going to say the sine of theta over 8, using the law of sines, is equal to the sine of 132 degrees, sine of 132 degrees over 18.3432. All right, so you go ahead and cross multiply and solve, and you get theta is equal to the inverse sine of 8 sine of 132 degrees, I'm not going to bore y'all with the details here, over 18.3432. And if I put that in my calculator, then hit enter, I get theta is approximately 18.9115 degrees, okay? So what did I just find here? I just found theta right here. Now what is my bearing? Think about this as a compass right here, this purple line and that line, okay? So my bearing is going to be 39 plus theta, right? So bearing is going to be 39 degrees plus that theta, 18.9115 degrees, okay? All right, so what does that give me? 57.9115 degrees? So if we think about that, that's this angle from here to here. So how is this boat going to be heading? What's going to be the bearing to get to the other boat? It's going to be what? Southeast. And how do I write that? South 57.9 degrees east. Those take a little bit of work. You got to play around with those quite a bit.